Now, we are going to be treating objects on an inclined plane. As we have on the board, objects on an inclined plane. This is a typical diagram of an object on an inclined plane. We have the normal reaction and acting in this direction. We have the weight acting vertically downward. In this case, the normal reaction is not equal to the weight because they aren't parallel to each other. We have mg cos theta. The normal reaction is parallel to mg cos theta. So we said the value of the normal reaction is equal to mg cos theta. We have the applied force. And then we have the frictional force acting opposite the direction of the motion or the direction of the applied force. And we have this, mg sin theta. This is called the component of the weight down the plane. Or we say the component of, or we say the parallel force down the plane. This force, the function of it is to bring something down. Once something is dropped or put on an inclined plane without any force acting on it, what everyone expects is that the next thing that happens is that the object rolls downward. What makes the object to roll downward is this parallel force down the plane. It's a natural force that brings objects down an inclined plane. Now, the normal reaction is never or not equal to the weight. And the coefficient of friction is equal to friction over reaction. Or we say F over reaction, normal reaction. N stands for normal reaction. Component of the weight down the plane is equal to parallel force down the plane, or mg sin theta. Now resultant force. Resultant force is equal to mass times acceleration. A stands for acceleration. Looking at the first diagram, it says if the object moves up the plane, what will the formula for the resultant force? The resultant force is equal to applied force minus the sum of friction plus parallel force down the plane should the object moves up the plane. For the object to move up the plane, that shows that the applied force is greater than the sum of the friction and the parallel force down the plane. B, if the object moves down the plane, the formula for the resultant force is equal to F, the sum of friction plus parallel force down the plane, minus the applied force. So, what we're trying to say here is that the sum of the friction and the parallel force down the plane is greater than the applied force. That is, for the object to move down the plane, the sum of the friction and the applied force is greater. The sum of the friction and the parallel force down the plane is greater than the applied force for the object to move down the plane. C, if the object remains at rest, that is, when there is no movement, the acceleration is zero. And when the acceleration is zero, the resultant force, which is equivalent to mass times acceleration, will be equal to zero, because mass times zero is zero. Therefore, R, resultant force, equal to zero. Force. So F plus mg sin theta, the sum of friction plus the parallel force down the plane, is equal to the applied force when the object remains at rest. D, if the object just begins to move, you have to be very careful when you get to, when a question like this is asked. If the object just begins to move, no movement has been recorded. That is, the object is yet to move. It hasn't moved. It is yet to move. No movement, no distance has been recorded. So we still consider the acceleration to be zero. If the object just begins to move, we still consider the acceleration, nothing has been recorded. So we still consider the acceleration to be zero. So the friction plus the parallel force down the plane, the sum of the friction and the parallel force down the plane is equivalent, or it is balancing the applied force. The resultant force is 0 because acceleration is 0. The second diagram, note that with this motion diagram, the object cannot move off the plane. The reason is that the friction cannot take the object off the plane. So it will only prevent the object from moving off the plane. It cannot take the object off the plane. So here, if the object moves down the plane, if the object should move down the plane, that shows the sum of the applied force and we have the applied force. Unlike this, we have the applied force here. But the reason why the applied force here is that in some cases, when an object is moving downward, you may want to quickly bring the object down the plane. So you have to apply some force. While applying some force, there will be, since you're applying some force, there must be a particular force which is going to try to prevent the object from moving downward. Since you're applying the force, there must be a particular force trying to prevent the object from moving downward, which is a frictional force. So it will act opposite the direction of the applied force. So if the object moves down the plane, we say the applied force, the sum of the applied force and the component of the weight down the plane, or parallel force down the plane, minus friction, that is resultant force, is equal to the sum of the applied force and the parallel force down the plane, minus friction will give us the resultant force if the object moves down the plane. In this case, now in this same case, in this same situation, if the object remains at rest, in the same situation, if the object remains at rest, we have the applied force, the sum of the applied force and parallel force down the plane equal to the friction, because the resultant force is equal to 0 due to the fact that the acceleration is 0. If the object remains at rest, the acceleration will be 0 and then the resultant force too will be 0. So the sum of the applied force and the parallel force down the plane is equal to the friction in this situation. See, if the object just begins to move, don't forget, just like we've said earlier, that if the object just begins to move, no distance or acceleration has been recorded. So the acceleration still remains 0. In this case, the resultant force too is 0. So the sum of the pulling force and the sum of the applied force and the parallel force down the plane is balancing or equal to the friction. Or we say the frictional force here is balancing the sum of the applied force and the parallel force down the plane. 3. When there is no force applied to the object, when there is no any force applied to the object, if the object moves down the plane, using this diagram, if the object moves down the plane, the resultant force is going to be, when there is no object applied to the object. But how do we get the friction? The reason why we have a friction there is because when there's no force applied to the object, this natural force, which is a parallel force down the plane, will bring what? Will bring the object downward. So while bringing the object downward, the friction will try to stop the object from moving. So that's the reason why we have friction there. If the object moves down the plane, md sine theta, the resultant force is equal to md sine theta minus F. That is parallel force down the plane minus friction. Resultant force is equal to parallel force down the plane minus friction. B, if the object remains at rest. If the object remains at rest, that is acceleration is equal to 0. The resultant force is also equal to 0. So when the object remains at rest, we have the parallel force down the plane equivalent or balancing the frictional force. All we say the frictional force is balancing the parallel force down the plane. They are equal to each other, so they are balancing each other. See, if the object just begins to move, the same thing applicable to when the object is at rest. If the object just begins to move, Nothing, the object is here to move. Nothing, no distance, no acceleration has been recorded. No acceleration has been recorded. Like when it is about to move, nothing has been recorded. So we consider the acceleration to be zero and the resultant force as well to be zero. The formula here is parallel force down the plane is equal to the friction, or we say the friction is balancing the parallel force down the plane. And don't forget, parallel force down the plane is also the same thing as the component of the weight down the plane. Now, in this case, to get the value of the coefficient of friction, using the formula friction over normal reaction, or F over M. Once you've gotten the value of the normal reaction, which is mg cos theta, then how do we get the value of the friction? The thing is that in each of every formula given in this situation, in all the formulas given from the first diagram to the third diagram, from A to C, in all the formulas given, make sure you make the F, which is the friction, which stands for friction, the subject of the formula. Make F the subject of the formula to get the value of the friction. So when you make F the subject of the formula here, you get the value of friction and bring it here to find the coefficient of friction. The same thing applicable to all other formulas given in these situations.